Okay, so this is just an explanation on how to do questions for chapter 9H for Spesh. The question has given us this integral, and they have asked us to find a formula, that we can use to find the integral of this. Now, in order to do this, we'll first need to use integration by parts, and then we'll need to use normal simple substitution to find this integral. It's very simple. It's just a bit of a long process, but we'll get there. So we'll first start off with integration by parts, and the formula for that is uv minus integral of v du. Now let's find our uv, du, and dv. So I'll make our u equal to x to the power n, making our du would be n times x to the power n minus 1 dx. Our dv is e to the power x dx, making our v that would make our v half times e to the power 2x. Alright, now if we sub all of this in, into this equation, it would give us x to the power n times e to the power 2x minus 2 minus integral of e to the power 2x dx. Now, we can simplify this further by taking out the 2 and the n, because they're constants. They have no x with them, so actually if we simplify this, we should get 2 integral of e to the power 2x times x minus 1 dx. I'll just bring that down a little bit. Alright. So if we have a look at this whole bit, it's very similar to what we have here, except the n over here is n, and over here it's n minus 1. So we can define this whole integral as in, and if we define this as in, then this would be in minus 1. So this whole thing would be in minus 1. And so this whole thing is equal to in because we used integration by parts to find the integral of in, which gave us this whole thing. So now what we can do is we can write in a simpler way. So we can just do x and we can just say times in minus 1, because this whole thing is in minus 1. Yeah, so this whole thing is equal to in minus 1. Now, in order to find x to the power 3, we need to sub in n is equal to 3, because here it's x to the power n, here it's x to the power 3. So n is equal to 3 in this case. In order to find when the value of I3, so when it's x to the power of 3, n is equal to 3. That means here we would need to find I3. But in order to find I3, we need to find I2, because here it would simplify to I2. Now, in order to find I2, so when n is equal to 2, we would need I1. And we'll see this as we expand and simplify later on. So let's just start with I3. I3, and because this means that n is equal to 3, we'll just sub in n is equal to 3 here. So that would make it x to the power 3, e to the power 2x on 2, minus 3 on 2, and then I3 minus 1. So that would simplify to this. Now see how there's an I2 in this equation now? That's why we need to find I2. So we can sub I2 into this equation. Let's go ahead and find I2. I2, now we sub in 2 for n. So n is equal to 2 now. 2 and 2. Now this is I1. We don't know what I1 is, but we can find out what I1 is by subbing in n is equal to 1. So I1 would be equal to x to the power 1 times e to the power 2x, 2 minus half. Now we have I0, but we don't know what I0 is. So let's find out what I0 is by making n equal to 0. So I0 is equal to x to the power 0 times e to the power 2x on 2 minus 0 on 2 times I0 minus 1. Now, when anything is to the power 0, it becomes 1, no matter what. So this would just become e to the power 2x over 2 minus, now this is 0 divided by 2 times I 0 minus 1. So if 0 is divided by something, it would become 0. And if 0 is multiplied by something, it would become 0. So this would become 0, all of it. So I0 is equal to e to the power 2x on 2. Now we have our I0. This is I0. So now we can sub this into here. We have no more i's. We don't have an I in this equation. So we have gone to the most basic and simplest form that we can possibly go to with this whole formula. So now we can start subbing in I0 into I1, and then we can find I1 and sub it into here. So let's go ahead and start subbing in. So this would become x times e to the power 2x, 2 minus I0 is equal to e to the power 2x on 2 over 2 because there's a 2 here. And then if we expand this, it would give us x times e to the power 2x on 2 minus e to the power 2x on 4. This is I1. So now we can sub this in over here. So I think you'll understand what I'm doing now. I'm just finding what I1 is, and then I'm going to find out what I2 is, and then I'll sub I2 into here to get I3. So let's sub in I1 here, x squared. This is an x, minus now the reason why this is a plus here is because we're minusing this whole thing. So if you have minus bracket, let's say like y minus z, this would become minus y plus z. So that's why there's a plus here and there's a minus here. So now we have I2, which is all of this. So now we can sub I2 into here. And I don't think I'll have enough room for this, but let's try. We're almost there. We've almost found out what I3 is. And then we sub this whole thing. I'll just copy it because I can't be bothered writing it again. Okay, this is all I2. And now what I'll do is I'll expand the brackets. So I3 is equal to, now I'm just expanding the brackets, to the power 2x and 2 minus 3x squared. And then it becomes a plus because here it's a minus, here it's a minus. Minus, minus, minus times minus gives you plus. This should be 2. Sorry, guys. This should be 2. I don't know why I wrote an X here. So this would become 4, and then +C. And there you go, that's your I3. And we have found the integral of this. So it was a long process, but it's quite simple, just complicated to identify. I hope that helps.